What is a graph? In graph theory is a mathematical structure used to represent relationships between objects. A graph consists of two main components, namely vertex node as a representation of objects, and edge as the connection between those objects. Formally, a graph is expressed as G equals V, where V is the set of vertices and E is the set of edges. In a graph, vertices function as representations of entities, such as people, cities, or devices, while edges indicate the existence of relationships or connections between those entities. These relationships can be physical connections, such as roads between cities, or non-physical relationships, such as friendships in social media. Graphs are used because they can simplify complex relationships into a more structured, easier-to-analyze form. By using graphs, various problems involving networks or relationships between objects can be solved systematically, such as pathfinding, connectivity analysis, and network optimization. Types of graphs. 1. Undirected graph, a graph that does not have direction on its edges, so the relationship between vertices is if A is connected to B, then B is automatically connected to A. Example, a two-way road. 2. Directed graph digraph, a graph that has a direction on each edge, so the relationship only applies in one direction. If A goes to B, it does not necessarily mean that B goes to A. Example, the follow system on social media. 3. Weighted graph. Each edge has a certain value such as distance, time, or cost. This value is used to find the best or most efficient path. 4. Simple graph and multigraph. A simple graph has only one edge between two vertices. In contrast, a multigraph allows more than one edge connecting the same pair of vertices. Graph representation. In graph theory, graphs need to be represented in a form that can be processed, especially in computer systems. This representation is important so that the graph structure can be used in various algorithms and data processing. Algorithma. In graphs. A. Pathfinding. Pathfinding algorithms are used to traverse vertices in a graph. BFS. Breadth first search. BFS works by exploring vertices in a breadth-wise manner, starting from one vertex and visiting all of its neighbors first, then moving to the next level. This algorithm is suitable for finding the path with the fewest number of steps. DFS. Depth first search. DFS works by exploring deeply, following one path until the end before backtracking and trying other paths. It is commonly used to explore all possible paths in a graph. B. Shortest path, used to determine the most efficient route from one point to another. Dijkstra's algorithm. This algorithm calculates the shortest distance by considering the weight of each edge, such as distance or time. The process starts from one point, then gradually selects the path with the smallest value until reaching the destination. Graph applications. Transportation graphs are used in navigation systems to determine the best routes. Applications like Google Maps and Waze model roads as graphs. Vertices equals intersections, edges equals roads. From this, the system can calculate the fastest route based on distance, time, or traffic conditions. B. Social media graphs are used to represent relationships between users. Each user is considered a vertex, and relationships follow friend are represented as edges. Examples include Instagram and Facebook, where graphs help analyze connections, recommend friends, and understand the spread of information. C. Computer networks. The internet is essentially a large graph. Devices such as computers, servers, or routers are vertices, while the connections between devices are edges. Graphs help in transmitting data so it can reach its destination efficiently. E. Biology and chemistry. Graphs are used to model structures and relationships in science. Examples include molecular structures, atoms as bonds as edges, and gene networks to observe relationships between genes in the body.